look at a really slow rate of speed for this dimensional analysis. We're going to look at a speed of 1 millimeter per second. That's how fast the common snail moves. So I'll talk a little faster so this won't take quite as long. Perhaps we want to take this rate of speed of 1 millimeter per second and convert it to something like kilometers per hour. So we're going to start with the rate 1 millimeter over 1 second, which happens to be a unit rate. It doesn't have to be a unit rate, but in this case it is, and that makes it a little more convenient. So 1 millimeter over 1 second. We need to find conversion factors to convert both the time and the distance. So for the time, we need to go from seconds to hours. We'll go incrementally. From seconds, the next unit of time up would be minutes. From minutes, the next unit of time up will be hours. So we need a conversion factor to eliminate seconds. The first thing to consider is my original rate of speed has seconds in the denominator. So I want a conversion factor that has seconds in the numerator. That means I want to use 60 seconds over 1 minute. That way the seconds will cancel out. For the next conversion factor for time, I now have minutes in the denominator and I want to cancel that out. So I want minutes in the numerator. So I should use the conversion factor 60 minutes over 1 hour. Now with these two time conversion factors, I will end up eliminating seconds and minutes, leaving myself with hours in the denominator. For the distance, let's see, millimeters, milli meaning 1,000th, so a millimeter must be 1,000th of a meter. That's a pretty handy thing to know. So the conversion factor I want needs to cancel out millimeters from the numerator. So I will need a conversion factor that has millimeters in the denominator. So I will use 1 meter over 1,000 millimeters. Next, to get from meters to kilometers, well, kilometer, kilo, 1,000. There are 1,000 meters in a kilometer. I want to cancel out meters from the numerator, so I want to get meters in the denominator. So I'll use a conversion factor with 1 kilometer in the numerator, 1,000 meters in the denominator. Now I've got this really cool expression, 1 millimeter over 1 second times 60 seconds over 1 minute times 60 minutes over 1 hour times 1 meter over 1,000 millimeters times 1 kilometer over 1,000 meters. All those units cancel out except hours and kilometers. Now I have straight fraction multiplication, so I multiply the numerators, 1 times 60 times 60 times 1 times 1. The denominator, 1 times 1 times 1 times 1,000 times 1,000. So I end up with 3,600 kilometers in the numerator, 1 million hours in the denominator. Now, I don't think this snail's going to be moving for 1 million hours, but if it did, it'd go 3,600 kilometers. So we probably want a unit rate, which would be more convenient for this situation. So the unit rate, meaning the denominator 1, we're going to divide 3,600 by 1 million, giving us 0.0036 kilometers per hour. That's pretty slow, but it's a snail.